Covering the syllabus dot point on the development of cathode ray television, including black and white and colour. First up, what is a cathode, or what is a cathode ray? As you know, cations are positive, are attracted to a cathode, which is negative. Cathode rays are essentially just beams of electrons. A cathode ray is an old school term for a beam of electrons. So a cathode ray tube heated up a metal in a gas and created electrons, which fired out, got focused through focusing coils, had a horizontal and vertical alignment with these pairs of plates. If I put a negative charge on there and a slightly positive charge on there, it bent it up, and it bent the electron up to that point. If I put negative on there, positive there, it bent it down and it put it to this point. So basically, a television set used to look like rows of electrons. They actually travelled down at a slight angle, shot back, travelled down at a slight angle. So that is what cathode ray tubes are. It's just a complete vacuum to allow the electrons to transmit, and off it went. And off the electrons go. On the inside of this cathode ray tube, you put a phosphor coating that glows when the electrons hit it. When it glows, it releases light. Black and white televisions were just a single screen of phosphor coating on the inside of the screen. And it just used to shoot beams of electrons across and draw a picture. How did it draw a picture? Let's have a look at it. A few key things before we go. The human eye needs to see at least 50 frames a second to, or the human eye refreshes 50 frames a second. Television in Australia works at 25 hertz. In England it works at 25 hertz. In the US it works at 30. Why? Because that's half of the frequency. In Australia the frequency is 50 hertz. Television works half of it. In America it's 60 hertz. So the 25 versus 30 hertz has nothing to do with television. It's got to do with whatever frequency the country runs at. The original cathode ray tubes were a 4:3 ratio because that's what the old 35mm film used to be. They used to shoot movies on the film, so they made the television the same aspect ratio as an old movie. No rhyme or reason, just seemed like a good idea at the time. Problem with that 50 hertz frame, the eye's got to see 50 frames a second to allow you to see a complete moving picture. What you are seeing here on the computer screen is at least 50 moving images a second. However, as you know, movies are only shot at 25. The computer then has got to split each image into two so you can transmit it and your eye actually sees a complete picture. It's basically got to do with the decay of the image. If I shine a bright light in your eye, then you see the light and then your eye adjusts. If I shine a bright light up the top of this screen as I'm transmitting lines of electrons across the top of a television screen, as I'm transmitting lines across the top, I'll change texture. That's better. As I'm shooting the lines across, by the time it gets to 1/25 of a second later, your eyeball has already lost that part of the image and it is seeing that screen as being dark. Television's got around that quite cleverly. Instead of transmitting line 1, line 2, line 3, line 4, they transmitted line 1, 3, 5, 7, 9, so they sent half the picture. Then they come back and they fill in the other half of the picture in a process called interlacing. That is the basic of cathode ray television. I'm now going to describe how black and white used to work and how colour works.